topic with science known as astronomy. When I was this small, I usually gazed up at the sky at the morning and the night. I was like, what's the difference in that? So I took my mother's mobile and I was searching. It was like dark, different and dark. There were sparkling things at night and morning. I was like, Mommy, look at these pictures. Why is that twinkling light and there only a large twinkling light? Why is there all the twinkling lights that has joined into one twinkling light in the day? My mother, my mother slapped some sense into me. Not this slap here. Might say explain to me. Okay, that's more easy to understand and not giving that slapping pain. Uh, she informed me that about the space and all. But she told me not to worry because my exams were coming at that age. Almost, not actually exams, but small tests at one junior school. Tiny, kindergarten like that, okay? My mother was like, don't care. Once you turn into second standard in school, you could care about all this astronomy and all stuff, okay? So I am fourth standard currently right now, so I think so I doubled that limit. So I have surprisingly learned a lot, and I can still say that's very little. I learned about a lot of stuff. Okay, pause the video and just think what can you think of with space. Now I'm going to continue saying, okay? I want to make this time short. So you all would have probably think of the Kuiper belt, the asteroid belt, comets, this thing and all. Lots of them, right? Well, it's kind of like a movie. Picture a movie. Okay, just like Guardians of the Milky Way. Okay, maybe a movie. There's of course going to be a villain, right? Every movie, just picture a movie, any favorite movie and all. It'll be a movie. There'll be a villain. Like that, there's a lot of villains in this universe movie. It's like black holes and all, but this one's only for black holes. So sorry, Magnetar and other destroyers. This one for black hole. Okay, VIP seat for black hole. Now I've probably told that villainous name a couple of million times. So once you're listening to the names, you might have heard it saying something black and it's a hole. So you all know it's going to be a black. Thanks to my amateur skills, you won't understand anything. So you might think, okay, it's black. I cannot see it, right? Well, it's black, but then the only way you can see it is the accretion disk or any other things like gravitational pulls or something just disappearing. So this accretion disk, ACCRE I'm very slow to the marker, okay? The accretion disk, it's like one giant dish just circling around it. Like how the rings of Saturn are made out of ice. This thing contains that tiny pieces of all that thing has eaten. All the stars, all the planets and all. It's around the accretion disk. So, well, I'm going back into some advanced level. So I would like to go back into basics. Mark. Now I've told you about a black hole, how it works and all. Everything sucks into it like gravity, okay? Okay. This black hole takes a lot of time, so I'll do a different video, but today it's the basics, okay? Basic school, kindergarten of black holes, okay? You can say like a massive star. You all seem to know stars, right? We need to draw the star in a sunny day. We have our own star. I'm not very good at drawing, so please excuse. I'm an amateur drawer in marker and in pencil, even in pen. My sister is the best. A star roughly 10 times the more mass than our sun. 10 times more mass than our sun. You might say everything has to come to an end, right? A packet of gummy bears you have, of course, will come to an end. A pack of pencils you had, of course, the pencil will finish off. A ink I'm holding right now, after a long time, it'll just go away. Everything has an ending, right? It's not like that line in algebra it has no end, starting or ending. It's not like that. it's kind of like a line segment in algebra. Just an example, okay? Don't need to learn, okay? Algebra for people who are smaller. 10 times more mass than our sun. And let's dive back into the star, okay? A star, you might look, okay, like our Earth, we have a core. The sun also has a core. Now, just think about something, a fundamental force in the universe. Gravity. I'm breathing right now. I'm living. That's very fundamental. You can say that gravity is needed for living. Just think. Atmosphere. Why is it that? Because of gravity. Oxygen. How can we breathe? Because of gravity. Right now. So, you can see that's very important for living. Okay? So, as this gravity, but the Earth's gravity also has some disadvantages. There's nothing but only advantages, right? In the world, sadly. Because of the Earth's gravity, I cannot grow very, like, in seconds I cannot grow this inches like that. I have to take some time so that I can defeat the Earth's gravity and move 1 inch up. Okay? That's why we eat a lot of protein so that I can grow a little up. So that because of the gravity is holding us down. So, a gravity like this, a sun so massive, right? It's millions of kilometers in diameter. Of course, I'm going to put every force inside, right? Well, then just think, a force is needed. If I'm pushing like this and I want it to stop, I need to put a force like this so that it goes back. So, inside a core, you do know some atoms, oxygen atoms bind together to get, I don't know, very complex names. Okay? But I do know that it releases a lot of energy while doing this. Okay? And when these two collide, it finally creates a hydrogen and helium atom. But yes, I know. Oxygen, helium, hydrogen. Okay? Hydrogen atoms is very complicated. I do not know how to draw. Okay? I am not very good learner. Just know atoms and all. Now, these hydrogen atoms, I've told you that when they crash, it creates a lot of force, right? Oxygen to helium, some little amount. Those little amount, as the core is very large, it creates a huge amount of force, which keeps like a delicate balance against this inward gravity force. Well, this is the basics I'm going to say now. When a star collapses, it means that all that oxygen and helium just turn into hydrogen, and it's finished. There will be no more core. All of it will just go towards it, right? Without the sun realizing, I don't know if the sun has some feelings, but I'll just say that, okay? Before you even realize, it happens in milliseconds. All that mass is pressured into one point. So it's like one point which is infinitely dense, a dense of the sun in just this point, okay? That thing is going to have a lot of gravity because the more mass, the more gravity. Understand? So once this thing collapses, it creates a supernova explosion where it scatters all of this thing. Fun fact, the supernova explosions release so much light that our own sun can release in its whole lifetime.
Oh.
It's really crazy. So once the supernova, either you leave it at this thing, but I've told you about it 10 more mass than our sun. If it was a sun who exploded, it will turn to a white dwarf. But that's enough for another video. This one,
The sun exploded?
our sun, the sun we have now.
Okay.
If it exploded, it will turn into a white dwarf. But that's another video.
White
okay?
dwarf.
Don't say it. You will get interested in it. Okay? The mass, more 10 mass is there. It turns to a black hole. Okay, now it's kind of jumped up. So you can conclude that, what do I say? A
When
black hole is born when a star dies. Sad. Like those movies. Where when the father dies, the son is born. Like that, okay? But except the sun is very evil. The black hole is the sun, okay? So, as you can see, a black hole, once it is born, it sucks up everything in it. But it's really difficult. It sucks up everything in its part. It sucks everything in. Well, that's how we know about a black hole, okay? It sucks like a vacuum cleaner. Cosmic housekeeping. Buy your own black hole and clean your house. Is that funny? No, I'm very funny. I'm not funny. I'm a pun machine. So if you're saying I'm not funny, don't worry. I'm still not sad. Okay. So this black hole over here, we just think. Okay, now I'm going to share a little bit of secret which was really shocking to me. I told you about large masses, right? Let's just think about short masses. Mass of the spin. I'm saying what I understand it once I read this, okay? Mass of the spin. It has some kgs, grams. No, there's no kilograms. Grams, right? So this everything in this universe has gravity. It's a fundamental force. It means that what do we say? This marker is attracting to me. This thing is attracting to me. It's like gravity because more the mass, more the gravity. Well, you told okay mass, but just think it's also called Schwarzschild radius. Very difficult, so you say gravitational radius. It's also one more name.
Can you tell it again?
Schwarzschild radius. It's very difficult to spell.
Okay.
This is the secret I want to share to you. What I read. Please don't bounce your head all around there. That's a lie, that's a lie. Are you ready? I'm not. That's what I thought. But okay, I'm just going to read this. We can turn to a black hole.
What?
Literally. We can turn to a black hole. As I told it. You might be like, come on, large masses, you just now told. Small masses, you can also turn. But chances of you becoming a black hole is very rare because a tiny gravitational radius. Isn't that relieving? Relieving that you won't turn into a black hole?
Okay.
Really. So, fun fact, time moves slower near a black hole. Inside, near, very far. Every place, in the world is different places. Okay, let's say Indonesia, different time. India, different time. While in space, if you go closer to a black hole, the slower the time. Well, what do I say that word? I forgot his name. Yep. I have blasted my brain with the basics, so thank you. If you want your brain more blasted, you can see the next video about the next black holes, okay? Advanced version. I'm saying you do not click that. My mind really exploded. But anyway, it's your choice, not my choice, not my brain. So, bye bye.